Analog devices and circuits, unit number 2, operational amplifier and its applications, APAM integrator. Okay, this is the one of the application of operational amplifier, that is integrator. So normally we know that the integration of sine waves, cosine wave, some other ways. So like that we are going to discuss in this unit, sorry, in this chapter. So here we are going to integrate the input signal using the operation amplifier. Operational amplifier can be configured to perform the calculus operation such as differentiation and integration. So this passive integrator is a circuit which does not use any active devices like op-amps or transistor. An integrator circuit which consists of active devices is called an active integrator. Okay, active integrators provide a much lower output resistance and higher output voltage than possible with the simple RCs. That is a passive integrator and active integrator. So normally we are connecting the capacitor in the feedback circuit. If we are connecting capacitor in the differentiator, it is in the non-inverting terminal. So that is called differentiator. So same as if the capacitor connected in the feedback between the input out output means it is called a integrator. Okay. If you are connecting the transistor instead of R1 resistance means it is called a active transistor, active integrator. Okay. So this is the derivation for the integrator, that is V in divided by R1 plus C into dV divided by dt is equal to 0. So if you are taking both side of integration means we will get V out of t is equal to 1 divided by R1 CF, that the integration of V1 of t and dt. Okay. So this is the model of ideal APAM integrator circuit. Okay, that is there is no circuit that is produces an output voltage which is proportional to the area contained under the waveform. An ideal integrator uses a capacitor 1 connected between the output and the APAM inverting input terminal. In the practical integrator, we are adding extra capacitor and a compensation resistor. We are adding feedback capacitor in the input and output side, as well as we add the R compensation resistance in the input side. Integrator applications. So APAM integrating amplifiers are used to perform calculus operations in analog computers. Integrated circuits are most commonly used in the analog to digital converter, ramp generators, also in the wave shaping applications. So another application would be integrator here, integrate a signal representing water flow, producing a signal presenting the quality of water that has passed by the flow meter. The application of integrator is sometimes called a totalizer in the industrial instrumentation trade. APAM integrator summary. The operational amplifier can be used to perform calculus operation such as differentiation and integration. So both these configurations use reactive components in the feedback part of the circuit. So integrated circuits are generally used to generate ramp waveform square wave input. So this is the input and output waveforms for the integrator. If you're giving sine wave means output will be a plus cos. Okay, normally it will be a minus cos if you integrate means. But here we are using the inverting terminal, so it is add again minus. So minus into minus it will be take a plus. So you will get a plus cos waveform. Okay. So then if you are giving DC waveform, so if you are giving DC voltage, if you are giving 2 volt means it will take the ramp output in the negative ramp in the output. So as well as if you are giving square wave input means output will be a triangular. Okay, இதெல்லாம் வந்து நம்ம input கொடுத்தா நமக்கு output கிடைக்கிற models. So this is the model of practical integrator. So see one by one. So this one is practical integrator, that is T is equal to 1 divided by 2 pi FA. So this is the circuit which APAM integrated with a DC gain control. To avoid the saturation of the output voltage and provide gain control, a resistor with high value of resistance can be added in the parallel with the feedback capacitor. So that is DC gain control. Okay, so we can use the integrator as the ramp generator also. Okay, next one, instrumentation amplifier. So this is the one of the important amplifier used in the operation amplifier. That is, using this instrumentation amplifier, we can amplify the very small signal. Okay, because most of the plant, the output sensors are placed in the different location, the different distance. So if you want to take data from the sensor means we cannot verify the physically by the any person. So we have to get the data. So the sensors always give the small variations. So we need to amplify this. So for this concept, we are using the instrument amplifier. This is the very high gain amplifier. So generally this refers the three APAM, that is A1, A2 and A3, three waveforms are used. Let's see one by one. That is stage one. Stage one, two APAMs are connected. That is I is equal to V1 minus V2 divided by R1. So this is the stage two. Stage two, that this recall virtual ground of APAM and the voltage divider, that is V minus is equal to V plus is equal to V2 R2 divided by R3 plus R4. These are the features of instrumentation amplifier. That is very high gain, very high input resistance, that is common mode rejection ratio, filters. So one of the application is interfacing strain gauge with the bridge circuit. Okay. So if you want to, if you like to measure small displacements or strains using strain gauges, so there are variable resistance and respond to the small changes in the strain or stretch, contraction. The sensor is mounted on. One is suggests a suitable application and a useful design to put the strain gauge in the bridge circuit design. So calculate the output of the following circuit for a very small DR changes with respect to the R value of the bridge elements. Okay, these are the integrator applications. So integrator mostly in real time it is used for generate the ramp signal and the sawtooth signal. A ramp means it will be a transfer signals.